Hello everyone, welcome to today's class. This is Teacher Simon taking you through ASPO Mathematics 1 paper 9709 stroke 12 for October-November 2021, and this is part 1 for questions 1 to 6. Question 1 is coming from trigonometry. Solve the equation, this one here, for theta ranging from negative 90 to positive 90. So what I can do is to cross multiply, okay, or multiply all through by the cosine of theta. So when I do so, I will be eliminating this. So multiply here by cosine of theta, you get 2 cos squared theta. Then here you will get 7 cosine of theta, and then multiply here by cos theta. Of course, that one disappears, we have a 3. Then bring this on this side, everything onto one side. We shall get a quadratic in cosine of theta. So 7, then cosine of theta, and then plus a 3, which is equal to 0. We can actually check whether this one is factorizable. Okay, this is a quadratic equation in cosine of theta. So let us use a calculator and then we factorize. I will go to mod, then equations 5, and then 3 is quadratic. Then we put 2, then there is a minus 7, and then we put a positive 3. We have a 3 and then a half. So I will say, I will skip some space here. Then I write cosine of theta is equal to 3. Then we also have cosine of theta, which is equal to a half. Now, in the exam, you don't do this, okay? That's why I left a space here. Why did I do so? It's because we need to show the examiner the attempt to solve the quadratic equation, okay? You can use the quadratic formula, substitute these values into the quadratic formula, and then from there you can write your answer. That is an attempt to solve. So here we have used factorization. So how does it come about? Give us the roots from which these values come. So bring this one back here. This one will be cosine of theta minus 3. And then here when I cross multiply, this one will give me 2 cos of theta. Then you can bring the 1 here, and then it will be a minus 1, like that. So by doing so, you have cheated the examiner. You see that? Then from here, of course, this one is undefined, because we know that cosine ranges from negative 1 to positive what? 1, okay? So when you get the arc cos of 3, the calculator will just tell you undefined, okay? Now we come to this one here, our theta then shall be equal to the arc cos of a half. But we have the domain here. They are saying that this is from negative 90 to 90. So it is 0. When you move anti-clockwise, the angles are positive. So this will be positive 90. And then when we move clockwise, the angles are negative. So this one will be negative 90. Now all angles, all the trigonometric ratios in the first quadrant are positive. It is only sign that is positive in the second quadrant. Okay, that is if this one is 180, then we have 270 here. Remember, I'm coming like this, okay? And then by the time you come back here, this will be 360. Now, it is only tan which is positive in the third quadrant, and then only cos that is positive in the fourth quadrant. Now, when I put arc cos over half, here I will get 60 degrees, okay? 60 degrees. But cosine is positive in the first quadrant and fourth quadrant. That means for me to get the other value, it can be, you have your theta here, and then theta here. So that means you can move from here up to here. And that one will be 360 minus the what? The theta. But the value you're going to get here is 360 minus the 60 you get. That will be 300. But this one is out of the range. So instead of going anti-clockwise, we instead go clockwise. You see that? So we shall move again 60 degrees and then we go here. But moving clockwise, the angles are negative. So that means we can also have what? Negative 60 degrees. So that is that. And another thing you should also know is that cosine of a negative angle is also equal to cosine of the positive angle. Why is it like that? Because when you go anti-clockwise with that acute angle, you are going to fall into the quadrant where cosine lies. You see that? Let's check this out. Cos of 60. What do you get? A half. What is the cosine of negative 60? It is also half. You see? So cos of a negative is equal to cos of the positive. So our two answers are negative 60 and positive 60. Question 2. The graph of y is equal to f of x is transformed to the graph of y is equal to f of 2x, then minus 3. Part A. Describe fully the two single transformations that have been combined to give the resulting transformation. Okay, of course, the first one here, we have y, which is equal to f of 2x. So x was multiplied by 2. This one is a stretch. When you see a multiplication on the x or on the function, that is a stretch. When you see an addition or subtraction, that will be a translation. Then when you see the change of sign of x or the function, then that will be reflection. You see that? That is the crack code, or we call it the cheat code. Now, this is a multiplication of the x, so it has to be the stretch by factor. This will be 1 over 2. Then parallel, which one was multiplied with? So they multiplied the 2 by the x, so it is parallel to x-axis. Why are we putting a half here? Let me show you where it comes from. Let's say we have our graph here, y, which is equal to, let's say, x squared. That is the one. But then we have y is equal to, so where there is x, I'm going to put, let's say, 2x here. And then we square. Now you see this one diminishes. Or I can use maybe the trigonometric function. Probably this one will bring it out very well. Let me use y is equal to sine x. So y is equal to sine x. This graph here repeats itself every after 2 pi. You can say this 2 pi. Then it continues. Okay. Now, if where there is x, now I put what? 2x. So we have y, which is equal to sine of now 2x. See what is happening. I've multiplied this one by 2, okay? But then the period has changed. It has become, it is here. This is pi, 0. Okay, you see 0 to pi, okay? It is repeating itself again. So do you see this? And this one will be now the 2 pi, you see? So the period moved from the 2 pi to pi. You see that? I multiply this by 2, but then the period was divided by what? By 2. So that's why we say it's a stretch by factor 1 over the value that is here, 1 over 2. So the period, which was 2 pi, multiply it by that half, then you get this new period, which is what? Pi. You see that? When I go back maybe to the quadratic one, we have y, which is equal to x squared. Okay, that is our graph. And then we also have y, which is equal to, we have 2x like that, then squared. So it diminishes, you can see. Now we can see here, in fact, let me try to zoom a little bit. For the same y coordinate you're seeing here, let me use another color actually. Let me use red. For the same y coordinate, which is 1 here, the first one, which is the blue, okay, we are seeing the x coordinate is 1. But for the same y coordinate, for this new one, the x coordinate is a half. So do you see that the x coordinate here was multiplied by a half? That is, this one here popped out. It comes out as a half. So do you see that? So that means when we have something multiplied with the x, okay, then the factor is going to be 1 over that multiple you put on the x, as simple as that. So that's why we are having what? A half there. And then this other one here, if I have then the 2x and then a minus 3, I said if there is an addition or a subtraction, then that is a translation. So when I come back to this one here, and I put, let's say, y, this one is equal to your x squared, and then we say minus 3. So minus 3, it is moving down. You see that? It has moved down by 3 units. So that is a vertical translation. Okay? If it's a plus 3 here, then it will move up. You see that? So meaning here we are going to have a translation by vector. There is nothing that is added or subtracted on the x, so that means the x movement is 0. And then in the y, we have that minus 3. So this is our answer. We have, it's a translation, the vector is this one, and then it's a stretch by factor a half, then parallel to x-axis. And that is that. Then the point P, which is 5, 6, lies on the transformed curve, this one here. Part B, state the coordinates of the corresponding point on the original curve. Okay, now remember, we have the original y coordinate, which we don't know, but the original y coordinate, this is the new one, okay, on the transformed curve. But remember, the y coordinate has changed by subtracting a 3 there. So that means the original one, if we are going back, then we have to add, not so. So what are we going to have here? I will say original y coordinate will be equal to the 6 here, then plus the 3. Take this one this side. You have y plus 3, not so, which is equal to what? A 9. So they got a 9, then subtracted a 3 to give you the 6 here, as simple as that. Okay? Okay, so the y coordinate was reduced by 3, so I just need to add back the 3. Then how about the original x coordinate? The original x coordinate. The original x coordinate is actually this 5 times 2, because there is 2 here. So this one will give us 10. Okay, remember, for y is equal to, let me put this one in brackets, for y, which is equal to 2x, okay, the x coordinate is divided by 2. Okay, is divided by 2. You remember on this diagram here that if you have y, which is equal to, then we put 2x squared. No, it's not like that. We have that, then squared. The x coordinate here, the original x coordinate, is now divided by 2 to give you this one here. But here we have a 2. You see that? So that is why I'm saying here that the x coordinate is divided by 2 to give 5. You see that? So we multiply, we therefore multiply 5 by 2 to get back our what? To get back the original x coordinate. As simple as that. Okay, so that means we are having 10, 9. This was the original point. Those are the coordinates of the original point on this curve. Question 3 is coming from functions. The function f is defined as follows. This is the one here. Find the value of f of 5. So what we need to do is to first get f of 5. So substitute here, you have 5 plus 3, that is 8. Then 5 minus 1, that is 4. So 8 out of 4, this one gives us a 2. Then f of 5 is the same as saying f acting on this result, okay? So the result of f of 5 is a 2. So what will be f of 2? Now substitute where there is x, put a 2. So 2 plus 3, that's a 5. And then 2 minus 1, that's a 1. So 5 over 1 will give us a 5. As simple as that. Then part B, find the inverse, the expression for the inverse. Okay, so suppose our inverse of the function is equal to y. I can take this one this side, and then we have x, which is equal to f of y. So in other words, interchange x and y. Okay, so where there is x, I'm going to put y, right? So that will be y plus 3. So x is equal to y plus 3 out of y minus 1. Then now make y the subject of the formula. So what do we do there? We cross multiply, and this one will be x, y, then minus x, then this one will be equal to y plus 3. Then I put terms that have gotten y on one side. So bring this on this side, then take this x this side, right? So we shall have x, y minus y, then is equal to, when this x crosses, it becomes a plus. So we shall have x plus 3. And then from here, y is common, so we factorize it. So y into x minus 1, then this one is equal to x plus 3. And then we divide all through by this, so meaning our y shall be equal to x plus 3, then out of x minus 1. So meaning f inverse here shall be equal to x plus 3 out of x minus 1. That is that. But if you look at this function, it is exactly the same as this. So this one, we call it the self-inverse function, okay? Since f of x is the same as f inverse of x, then f is called a self-inverse function. Okay? One time they can ask you such a question. So that is that. Question 4. The curve is such that dy dx is equal to this. The curve passes through this point. Find the equation of the curve. Of course, we are supposed to integrate here. So y shall be equal to the integral. Take this one up. So we shall have 8, then 3x plus 2 to the power of negative 2. Then with respect to x, we increase the power by 1. Remember, when you begin the process of integration, you take away the integral sign. So you have 3x here plus 2. And then increase the power by 1. So negative 2 plus 1, you get a negative 1. Then you divide by that new power. But then times the derivative of this one here, which is a 3, because this one is coming from differentiation using the chain rule, okay? Then, of course, we need to put a c here, an arbitrary constant. We don't know the constant that disappeared when they differentiated, okay? So that means y is going to be equal to negative 8 over 3, because this one is a negative, and we don't write a negative in the denominator, so that's why I'm putting it here, okay? Then this one can go down using rules of indices, so this will be 3x, then plus 2, just like that, then plus c. And then from here, we need to find this value of c. If a point lies on the curve, then that means that its coordinates must satisfy the equation of that curve. So if this point is on the curve, which is 2, then 5 times 3, that will be 15, then plus 2, 17 over 3. So we substitute in here. We have our y as 17 over 3, which is equal to negative 8, then out of 3 into 3 times 2, then plus the 2 here. So we shall have 17 over 3. When, of course, this one crosses, it becomes a plus. So plus, this will be 8. Then out of 3 times 6, what do you get? 3 times 2, you get 6. Then plus 2, you get 8. Not so? So if you get 8, then there is a 3 here. And then that 8 there. So this 8 will go. That means I have 17 over 3, then plus 1 over 3. This will be 18 over 3. And 18 over 3, that one will give us a 6. Not so? So meaning that we shall have our C, which is equal to 6. So the equation of the curve will therefore be y, which is equal to negative 8 out of 3 into 3x plus 2. If you want, you can multiply out the brackets here, then plus 6. And that is that. Question 5. The first, third, and fifth terms of an AP are these ones here, respectively, where x ranges from pi over 2 to pi. And then part A, find the exact value of x. Now, the first term is 2 cosine of x. Okay, then the third term is a plus d. No, a plus 2d, which is equal to negative 6 root of 3, then sine of x. And then the fifth term, which is a plus 4d, then is equal to 10 cosine of x. So right from here, I can have 2d, which is equal to negative 6 root of 3 sine of x, then minus a, which a is 2 cos of x, not so? So meaning d is going to be, right from here, I can have, you divide all through by 2, so you have negative 3 root of 3 sine x, then minus cosine of x. Okay, and then from here, I can now come to this side here. So we have, let me take this one here down. So we have our a, which is 2 cos of x, then plus 4, then d is negative 3, okay, root of 3 sine of x, then minus the cosine of x, and then this one is equal to 10 cosine of x. And then now you can see that everything is in terms of x. Now we can solve this trigonometric equation. Now we have 2 cosine of x, then minus 12 root of 3 sine of x, and then 4 times this one, so it will be negative 4 cosine of x, which is equal to 10 cosine of x. So I need to put cosine onto one side and then sine onto one side, right? So we can have negative 12 root of 3 sine of x. This is 2 minus 4. That's a negative 2, not so? A negative 2, then when it crosses, it becomes a plus. So we shall have 10 cos x. In fact, let me leave this one as negative 2 cosine of x here for my work to be so systematic. So that is that. Then take this on this side. Then you will have the negative 12 root of 3 sine of x, which is equal to what? 12 cosine of x. So we can divide all through by 12. Divide all through by 12. Yes, it is common, but also cos of x. So negative 12 root of 3 sine of x, then divide by, we divide by 12 cosine of x, and also this side 12 cosine of x, we divide it all through. That means here you are getting root of 3, then tan, because sine over cosine is a tan, right? Then is equal to 1. Of course, it's a minus, so meaning tan x will be equal to negative 1 over root of 3. So meaning x will be equal to the arctan of negative root of 3. And we know that tan is negative in the second quadrant here and the fourth quadrant where we see the cosine. It is positive in the first quadrant and third quadrant. So it's a 0, then we have pi over 2, then this will be pi, then 3 pi over 2, and then by the time we come back here, this will be 2 pi. So if I project an x here, and then also down here, opposite angles are equal, then we also have here, and then here. But our domain, it is saying that x ranges from 90 to 180. That means we are supposed to consider the second quadrant. So we are moving from here to here, which is pi minus the x there. Okay, now you ignore this negative. Okay, remember we are supposed to pick angles from the quadrants where tan is negative. It is here and here, but based on the domain, then we are supposed to be in the second what? Quadrant. Are we there? So ignore the negative. When you ignore the negative, you will get the arctan of 1 over root 3, which is 30 degrees, and that is pi over 6. But then you subtract it from the pi here. So to get the angle in the second what? Quadrant. When you put this one directly in the calculator, you'll get negative 30. And it is not in our domain. So negative 30, then you move back like this. Because remember, when we move clockwise, the angles are negative. Okay? So it'll be negative here. So you get the pi, then subtract off that 30. You get that? So meaning here we shall have this one equal to pi, then minus pi over 6. And this will be 6 times 1, that is a 6, then minus 1, then you get a 5. So we shall have 5 pi over 6. That will be our answer. So I will say that x is equal to 5 pi over 6. That is that. Okay, I think I need to extend these ones a little bit here. So that is that. Then part B, hence find the exact sum of the first 25 terms. So we need to get the first term. Remember, the first term is given by 2 cos x. So we have 2, then cosine of our x is 5 pi over 6. Cos of 150 is the same as negative cosine of 30. That is negative 3 root 2. Negative 3 over 2, then times the 2. So we get negative root of 3 here. Negative root of 3. They said exact. So leave this side there. And then we need to get the common difference. So how do we get the common difference? Right from here. This is the one, okay? Is it the one that we are having there? Yeah. So it is negative root of 3, negative 3 root 3 sine x, negative 3 root 3 sine of this 5 pi over 6. And then we subtract what else? We have cosine. That is cosine of x, which x is 5 pi over 6. Sine of 150 is a half, so we have minus 3 root of 3, then times that a half, then minus, because cosine of this one is negative root of 3 over 2, so this one will become a plus. Then we have minus 3 root of 3 plus root of 3 over 2. This one will give us negative 2, then root of 3 over 2, and then we get negative root of 3, not so? So our D is negative root of 3. So sum of the first n terms of an AP, we know it is n over 2, then into 2a, then plus n minus 1 what? D. Already, okay, this is sum of the first 25 terms. So we have 25 out of 2 into 2a. So 2 times this one here, then plus 25 minus 1, that one will give us a 24, then times negative root of 3 as our D. So you have 25 over 2, and then inside here you have negative 2 root of 3, then minus 24 root of 3. Sides are said to be added or subtracted if the number under the square root sign is the same. So we have a root of 3 and a root of 3 here, so that means we can simplify this. So negative 2 minus 24, that will be negative 26 root of what? 3. So this one goes here 13 times, not so? So what is 13 times 25? 13 times 25, we get 325. So that means our answer here is going to be negative 325 root of 3. As simple as that. Question 6. The second term of a GP is 54. Second term, that is AR, is equal to 54. The sum to infinity of the progression is 243. Sum to infinity, which is A out of 1 minus R, is equal to 243. Then next, the common ratio is greater than a half. Our R is greater than a half. Then find the 10th term, giving your answer in the exact form. Okay, right from here, I can say my A is going to be equal to 54 out of R. So meaning I'll have 54 here out of R. That is the A. Then it will find this 1 minus R down here. This R will find it. And then this one is equal to 243. That means here I can have an equation in R. I solve. This one is going to turn out to be quadratic. I get two values, but the value of R I'm going to take has to be greater than what? A half, not so. Now, what else do we have? We can cross multiply. You have this 54, which is equal to 243 of R, then minus, of course, R times R, that is R squared. So we have 243, then R what? Squared. Bring everything onto one side to form a quadratic. 243R squared, then minus 243 of R, then plus the 54, then is equal to 0. But 54 is divisible by 3, and also this one. Not so. Let's check and we see. Because when we have the quadratic equations, always simplify them. 243 divided by, let's say, 9. You get a 27. Even 54 is divisible by 9. 6. So, okay, but again, there is another 3 that can be divided here. Okay, 243 divided by how about 27? Then again, 54 divided by 27. Okay, so I can divide all through just to simplify, but still you can deal with this one, no problem. Divide all through by 27. So we have seen that this one gives us a 9. 9R squared minus 9R, then this one is a 2, which is equal to 0. So this is a quadratic in R. We can solve it using factorization. So let me use a calculator. Mod, equation is 5, and then quadratic is 3. Then we have 9, then negative 9, and then positive 2. So we get 2 over 3 and then a third. So I will skip space, and then I write R is equal to 2 over 3, and also r is equal to what? A half, a third. But then I'm supposed to show the examiner the attempt to solve this quadratic equation. So give us the factors from which these roots come. So cross multiply, that one will give you 3r, then bring the 2, it will become a minus, so that is minus 2, and then also cross multiply here, that one will give you 3r, then bring the 1 here, that one will give you minus 1, which is equal to what? 0. Now, this one here is 0.6666 recurring. This is 0.333 recurring. So which one is greater than the 0.5? It has to be this one here, okay? So that means that for r, which is equal to, for r, which is greater than a half, then my r is going to be equal to 2 over 3, like that. Remember that you want the 10th term, so I need to get the first term and then the common ratio. So we have the common ratio, then what will be our a? So use this one here, that is 54, then divide by the 2 over 3. What do you get here? The 2 will go in here 18 times, not so? No, that is 27. So 27, then this 3 will somersault and then multiplies with that. So 27 times 3, that one will give us 81. Okay. Then after that, we can now proceed and find the 10th term. So the 10th term of of a GP, I was going to say of an AP. So this one is a, then r to the power of 9. We shall have our a as 81, and then our r is 2 over 3, then to the power of 9. So we're going to put each and everything. Do they want the exact value? Yes, they said give your answer in the exact form, so don't put decimals there, okay? We have 81 into, then 2 out of 3, then power 9. We have 512 out of 243. 512 out of 243. That is the exact answer. So you leave it there. So this has been it for this first part of the paper. Thank you so much for watching. May God bless you. If you find the content very helpful to you, kindly like, share, and even subscribe. See you in the next videos.